Alright, this video is going to review the three-dimensional figures and volume and surface area. Alright, here you are asked how many more edges does a rectangular prism have than a triangular prism? Okay, remember a prism has two bases and then it's named according to the shape of the base. So this rectangular prism, if you were to draw this out just so that you have a visual, that means you have a rectangle base. Notice I'm not drawing it sitting on its base. Okay, and there are two of them. So you would just have to draw two congruent rectangles, and then you connect the four corners. So this would be a rectangular prism. Now a triangular prism has a triangle base. So you would draw yourself a triangle and a second congruent one and connect those vertices. Okay, so there are the two shapes that they're referring to. A lot of people, it helps to have a visual. Okay, so now they're asking about the edges. Edges are the line segments where two faces meet. So here in the rectangular prism, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And the triangular prism, I have 1, 2, 3, 4, 5, 6, 7, 8, 9. Your answer is not 12 or 9. The question is how many more edges does the rectangular prism have than the triangular? So 12 minus 9 is 3. There are 3 more edges in the rectangular than the triangular prism. 9 asks you to draw or name a polyhedron that has the same number of faces as a square pyramid. Remember, a polyhedron is made up of polygons. It's a 3D figure that's just enclosed by polygons. That means no circles. And they want the same number of faces as a square pyramid. If you can't picture it in your head to count the number of faces, again, you could draw a square pyramid. So you have a square base. Remember, a pyramid, there's just one base, and then all of the vertices of the base come up to a common vertex, which means all of the faces, lateral faces, are triangles in a pyramid. So we've got the left, the right, the front, and the back, and the bottom. So that is a total of 5 faces. Now they want another polyhedron that has the same number of faces. Well, if you think about it, they technically said square, so you could do any other quadrilateral base on a pyramid. So I could just do a rectangular and just show that it's not a square, so it is different. But if I make this a pyramid, there are still 5 faces. There's still left, right, front, back, and base. So you could draw or list a rectangular pyramid, or what they're really trying to get you to think of is probably not a pyramid. They're probably wanting you to think more of in terms of prisms. What prism has the same number of faces as a square pyramid? So what prism can you think of that would have 5 faces? So in that case, you would need, you have to have 2 bases to make it a prism. So that would leave 3 sides. So that means that the base would have to have 3 sides. So that makes it a triangle. So that would be a triangular prism, just like we drew in the last problem. If I have a triangular prism, that wasn't the best drawing, but I hope you get the idea. You have the 2 bases plus the left and the right and the bottom side. So that is a total of 5. So that could be another possible answer. Triangular prism. So either of these pictures or words would be the correct answer for number 9. All right, last but not least, number 10 here wants to make sure you're able to identify 3D figures from a net or a solid perspective. They want you to be able to number the faces, edges, and vertices, okay? You're going to need to know more than just these, but this is a good start. Okay, remember when it's a net, that just means it's folded out flat. If I were to fold this back up, I would have my solid. So if you look at the shapes here, these are all triangles. When you have triangular faces, it's going to be a pyramid. Okay, so 3 of these are going to fold up and meet at a common vertex, leaving this as my base. So the base is a triangle and the lateral faces. So it's a triangular pyramid. Now, as it goes for number of faces, edges, and vertices, the net is a really good way to see the number of faces because it's all laid out and you can just count them. So there are 1, 2, 3, 4 faces. Now edges, it's harder to see when it's laid out as a net because you'll repeat some of the edges when you're counting. So if it helps you, draw it, fold it up. So here's my base, and I'm going to draw these all coming to a common vertex at the top. So the number of edges, of course, the 3 edges of your base, and then all of the edges coming up to that common vertex. So 1, 2, 3, 4, 5, 6. So 6 edges. And vertices are the corners where 3 of the edges meet. So in this case, there are 4 vertices. Don't forget, I misspelled that. Don't forget, you can always use Euler's formula to check if that's true. The number of faces plus the number of vertices minus 2 will equal the number of edges. Okay, that's going to be true for all of your prisms and pyramids. It will not necessarily be true for your solids with circles. So if you check that, is 4 plus 4, because that's faces plus vertices, minus 2, that would be 8 minus 2 is 6, and that's what we said, so that one does check out. All right, now for this, hopefully you know when there's 2 circular bases, that is a cylinder. Each of the bases are considered faces, okay, but the rounded part here, connecting them, okay, that's not a flat surface, and we're talking about faces as in flat surfaces. So there are only 2 faces. Edges is confusing because typically we think of an edge as a line segment, so it has to be straight, but really an edge is also the circumference of a circle. This is the edge of the circle, okay? So there's 1 and 2. So 2 edges. Right, now your vertices are the points where edges meet. Well, none of our edges meet, so there are 0 vertices. Hopefully you can remember that this is the net of a cone. If I were to fold this up, this rounded piece would overlap the circumference of the circle and come up and look like this. Okay, it's a cone. So this is the one edge. So one edge. Okay, the base here is the only flat surface, so one face, and then you have one vertex here. All right, this is a 1, 2, 3, 4, 5-sided, and there are 2 of them, so it's a prism. Pentagonal prism. Okay, 2 bases and 1, 2, 3, 4, 5 lateral sides leaves us 7 faces. Edges, 5 on this base, 5 on this base, plus the 5 connecting them is a total of 15. And vertices, 5 on top, 5 on bottom, for a total of 10.